Hi ladies, this is lesson 6.2 and it's about compositions of reflections. So that's reflection after reflection. So in this lesson we're going to look at two different types of reflections or two different types of compositions. The composition of reflections across two parallel lines and the composition of reflection across two intersecting lines. So if you remember the difference between, or one major difference between reflections, translations, and rotations is that a reflection orientation changes. In a translation and a rotation, orientation stays the same. Okay, so in this lesson, that's kind of an important key concept. And again, we talked about this previously, if you look back to chapter 3. But reflection over one single line of symmetry or one single line of reflection, the orientation changes, it flips, it gets reversed. So in this lesson, on your note sheet, you have these steps listed out. So I'm not going to do it on patty paper, but I'm going to do it in the Smart Notebook so that you can see. So first thing I want you to do is draw a figure, and it can be any figure. All right, so here's my figure, and you can draw that on a piece of tracing paper or a parchment paper, or if you have patty paper, that works too. Or you can just do it on a piece of white paper and use a marker so that you can see through. And then the second step is to fold to reflect your image across one line of reflection. So let's say that this is my line of reflection. I'm just going to fold my paper right here, and I'm going to reflect this image. Okay, so you can, again, you can use it by tracing. So fold on your paper and then trace your original image. And now the next step is to fold a line that's parallel. Okay, and it's important, it has to be parallel. It doesn't have to be super close to your image, but it does have to be parallel. And then you should reflect again. So now reflect your second. I'll change the color of this so that you can kind of see the difference. So now I'm going to reflect the blue image over that blue line. And then when I did that, I got my purple image. Now, if you compare the black image to the purple image, what do you notice about orientation? The orientation of the black and the purple image is the same. So if you reflect the image once over the green line to get that blue image, orientation is flipped. Now, if you reflect it again to get the purple image, orientation is back to the original. Now, one of the questions on your note sheet is to look at the first image and the third image. Is there a single transformation that could transform that original image to the second image? Well, let's look. It can't be one single reflection because the orientation is the same as in the original. It's not a rotation. Well, it could be a rotation of 180 degrees, but really the best answer here is translation, because from each point to its image point is exactly the same distance, and all of these vectors are parallel. So the single transformation of a reflection across parallel lines is a translation. Now the second question is to use a compass to measure the distance between a point in the original figure and its second image point, and then to compare the distance between the parallel lines. How do they compare? Well, I'm going to use my ruler, and between the two parallel lines, I got 4 centimeters between the parallel lines. And now between my 2 images, from a single point to its image point, I got about 8 centimeters. So that leads us to our first conjecture, and that's that a composition of 2 reflections across 2 parallel lines is equivalent to a single translation. So we looked at that, the translation vectors. And then secondly, the distance from any point to its second image point under the 2 reflections is twice the distance between the parallel lines. So in my example, the distance between the parallel lines was 4 centimeters, and the distance between an original image point to its second image point is twice that, which was 8 centimeters. All right, the second part of this lesson is talking about reflections across 2 intersecting lines. So again, we're going to draw a figure, and it can be, you know, whatever you want. Mine's probably going to look similar to the last one, but you want to draw a figure that doesn't have symmetry. Because if you draw it with symmetry, it's kind of going to be hard to see the pattern. But okay, so here's my figure. There. Kind of looks like maybe a hungry dog or something. Or a bird. All right, so here's my figure. And I'm going to reflect it across 2 intersecting lines. So whether you have, again, paper or patty paper, or you're just sketching these out, if you do it on paper, you're going to need to use a darker marker, but parchment paper or wax paper or patty paper, all will work fine for this. So now reflect your image across that 1 fold line. Okay, so once you have your first image reflected, the next step is to draw another fold line, and you're going to reflect your second image. So again, let me change this color to blue. So I'll reflect it over to the green line, over the blue line. We'll make this blue too, to get the blue image. And then we're going to draw another line of reflection that intersects here. And your line of intersection can be anywhere, but it just has to intersect. So you would want to fold your paper again and then reflect the blue image or the second image over that second line of reflection. All right, so if you look at my diagram, this green image is my second reflected image. So now what I want you to do is I want you to emphasize that point where those 2 fold lines. Mine are the green and blue lines, but yours may be fold lines if you use patty paper or parchment paper or just regular paper. If you look at this point, I actually had my second image in the wrong spot, so here, or my second reflected image, so here you can see actually this black figure reflected over the blue line is the blue figure, and the blue figure reflected over just the green line is that green figure. All right, so again, I'm going to focus on the 2 images I'm going to focus on are the green one and the black one. And the green one is my second reflected image, and my black one is my original. So in my original image, I'm going to focus on this dot right here, right in the middle of the figure, and that's going to be my my point that I'm going to look at that corresponds with my green image. So in your intersecting lines, this point right here, that's the point of intersection. So for a second, let's just focus on this point. And what I want you to do is with your protractor, measure the acute angle between those intersecting lines. So here is an obtuse angle, but I'm measuring the acute angle. So let's look at the acute angle between my intersecting lines. And here I get about, let's say, 58 degrees. That is my acute angle measure between my intersecting lines, 58 degrees. Now I'm going to look at a corresponding point between my original image and my second reflected image. And with that corresponding point, I'm going to draw two segments. One that connects that special point to my point of intersection. And then the second segment from that special point to the point of intersection between those two lines. So now this forms an angle. Those two segments that I just drew forms an angle. Now with your protractor, I want you to measure the degree of that angle and tell me what you notice. Okay, so if I were to measure this, well, it's giving me the acute measurement, but here, this is about, make sure that's on my point. I'm not sure why that gives me 29 degrees, but if you look at your protractor, here's my original segment, or my flat segment at 0 degrees, and then all the way over here, that's about 116 degrees. So if you look at a pattern, and yours is going to be different numbers, but if you look at the pattern, the degree of rotation, so if, rewinding just a minute, if we were looking, if we were looking for a single transformation of a composition of reflection over two intersecting lines, this would be a rotation. And secondly, the point of rotation is the point of intersection. And then lastly, the degree of rotation is 2 times the degree of the acute angle formed by intersecting lines. So again, my original image reflected over the blue line is the blue image. The blue image reflected over the green line is the green image. My acute angle measure is 58 degrees of those intersecting lines. And my degree of rotation, therefore, is 116 degrees, and that's clockwise. Now, it's possible that yours was maybe a rotation counterclockwise. That's okay, but it would be 116 degrees or twice of the acute angle is going to be the shortest rotation. So it might be clockwise, it might be counterclockwise. If I was looking for my counterclockwise measure, that would be the measure of this angle. And how would I find that? I would have to take 360 degrees minus 116 degrees. Oops. 116 degrees. So counterclockwise would be 244 degrees. So please jot down any questions you have from this lesson, and we can go over them next time in class when I see you. Thank you.